So those of you who've been playing a bit now, what's your initial impression? Is it fun? Yeah, it's fun. Yeah. It is fun. I find it fun. It's especially fun if you have someone who's really good visually, because they will start, giving you ideas of how to do things, make them look more spiffy. And if you're a programmer that likes to create things, it's really nice to be able to not only create them but also make them spiffy at the same time. If you have, someone who can help you with that. So I find it's fun. All right. So what we'll do next is or rather Steve will walk you and talk you through this bouncing ball animation example, which we only saw a still of so far, quite purposefully because we want to develop this kind of in a step-by-step fashion. So yeah, I think it's 5 or 6 steps.
All right. So we'll just talk you through the concepts which Till has already explained and show how they're put into practice with this bouncing ball. I'm actually going to start by showing you the demo so you can see what it does. Yeah. So when the demo starts, the ball is at the bottom and it jumps up to the top and then bounces down to the bottom again. The way that's done is we have the image again with this ball referenced. It's just a QURL. So we reference the ball.png. We say that the ball should be in the center of the scene. And we say that the number animation on the Y component, the Y property of the image should be animated. We say that it should animate from the value of 20 to the value of 200, quite easy. And we say that it should have the outbounce easing type. I'm just going to change that to out quad, just so we can see the difference. So you see the difference there, where it doesn't bounce anymore, and it just quadratically tends to the value which I've set in the animation. And again, I'll just make it linear so we can see again. No change in speed there at all. So you can experiment with the different easing types that are built in. There is quite a few of them. Yep. Next step in that lab is to say that we want to have 2 number animations this time, and we're going to do them in sequence. The image is still the same, the scene still has the same dimensions, the same width, the same height, and the ball is still in the same place. That is going to change later in the lab. But we do see that we have a sequential animation on the Y property again, and contained within that animation is 2 number animations. And we don't have to specify again that these are both on the Y property of the image. That's already implicit by the parent animation. That is the sequential animation element. So if we look at this one, we can see that rather than in the previous example, in the previous step, we did not see the ball start at the bottom and animate up. It simply was up there and animated back down. So now we have 2 number animations. The first one makes it start at the bottom and go up, and the second one makes it go from the top down to the bottom. So we quadratically go from the bottom up to the top in a quarter of a second, and we bounce back out. This part was in the first step of this example. From the top, which is 20, down to 200. So the Y property has its 0 value at the top, so that it doesn't quite reach the top when it bounces, and it doesn't reach the bottom either because of the height of the scene. The scene has a height of 300, and we only animate down to 200 here. So yeah, so far we've got an animate up and an animate down. The next step is a lateral animation. We're going to animate from one side to the other, while at the same time animating up and down. So the way we do that is we have a number animation on the X property of our image, our ball. And we say that we animate from 20. X has its 0 value on the left-hand side. So we animate from almost the edge to 500, which is also almost the edge on the right-hand side, because the width is 600. And at the same time, we have our sequential animation, which I showed in the last step. There's kind of an implicit parallel animation around these two, because they're both top level. Any top level animations like that will be run in parallel. So the effect can be quite easily seen there by adding the animations. The next step is to add some rotation to the ball. I'm not sure if a tiger would rotate when he's bouncing at you. Maybe Tigger would, but here we have a ball which rotates when it bounces. And that also, whoops, that happens at the same time as the, oops. Yeah, that happens at the same time as the bounce up and down. So all three of those animations happen in parallel. And I'll just again show that. So we have a number animation. We're animating from left to right. Where we have a double animation, a sequential up and down animation. So we go from down to up and then from up to down. And we have a rotation. And we say that we're going to rotate clockwise. I can just change that to anti-clockwise to see the effect.
Isn't it counterclockwise?
Yes, it is.
See, it actually does the squiggly line. That's how I noticed it's wrong. It's not because I know better than Steve, but creator told me.
That didn't work at all.
I think counterclockwise with a capital C. No? Well. Yeah, that helps.
So now you can see that it's actually animating the other direction, which does not look natural at all. So you do have to be careful when you're designing your animations that they actually help. Don't use too many. Excuse me. Don't use too many of them, and make sure that they do help towards understanding what's going on in the UI.
There's a pretty good rule for animations, which says that animations naturally draw the attention of the user, and the attention of the user is a very, very scarce resource, right? Generally, software is supposed to get out of the way rather than in the way, at least ideally. And if you use animations, you kind of force the attention of the user to something. First of all, you force it to the application, and you force it to a particular part of the application, because, you know, something moves, probably a tiger, so, you know, user is very alert. And that's why they get so annoying so quickly, because if you have too many of them, they constantly force you to register what's going on, because you're just biologically inclined to do that. So whenever you need to draw the attention of the user to something, it's a good idea to animate whatever that is, which means if you are exposing a user interface element that the user now needs to interact with, it's a good idea to animate it. If you bring in a user interface element that the user is supposed to ignore at his leisure or her leisure, then you better not animate it, because they will look at it as soon as you animate it. So the basic rule of thumb is, if you need to draw the attention, animations are a very good way of doing that. If you use an animation, you will draw the attention, so be careful with that, because users don't really like it.
So in the lab handout, the only difference now between what we have here and the final version is a simple gradient. So that's what it looks like. So a gradient and a mouse area. So now we have to click the ball to actually make it animate. And we do that with some tools that we've already learned over the last few hours. We have at the top a gradient specified in the usual way with some gradient stops. Not all that interesting, so I'll just skip over that. And now we have a mouse area on our ball image, specifying that when we click on the image, the animation should be run. Its running property should be true. And so the rest of it is largely unchanged, but the animations are not run automatically anymore, because it's not a sequential animation on X anymore. It's just a sequential animation. When we say that we had a number animation on X, that made it start automatically, and we no longer want that. We want to start the animation when we click the ball. So we took that out and we put in the mouse area for control. Oops.
You have to do the continue thing.
And so we get the effect that we want.
So do you guys know the Angry Birds game? Yeah, who knows that one? iPhone users, N900 users. So given these tools that you've been introduced to now, how much of that game would you not have any idea how to do? Not terribly much, right? It's pretty spiffy for 3 hours. So I hope you agree at this point that this is actually really powerful stuff. You can get, a lot of functionality done in very, very little code and very little time. Obviously, the polishing then takes just as long as it did before, and all of the logic errors will still be in there. But in terms of getting results really quickly and getting something really visually pleasing very quickly, this is awesome stuff. And for software where the value isn't in the polishing, right, but rather in the novelty aspect or in the branding aspect of it, a lot of software is like that. This is really good because it allows you to do that much, much cheaper than before. Okay. Thank you, Stephen.
Sure.
Another just few creator things here and there. Yes, you've seen the completion at work. It also does quite nice context help, and it does highlighting. So if you're referencing something that has an ID somewhere else, it will highlight the corresponding item. So that's quite nice. Someone was asking me in the break whether it's possible to write QML files with other editors or whether you have to use Creator. QML is text, so you are free to use VI. The benefit of Creator, there's the editor, which is rather nice and has all the syntaxy highlighting things and all that, but the benefit really is the integration, because you download the SDK and Creator and you have something that you just start typing QML and you hit the run shortcut and it will just work. That's really quite nice. Yes, you can do all of that on the command line. You can run the QML viewer manually. You have to be in the right directory and you have to maintain all of that infrastructural stuff. So it's really just convenient. Of course, you can still write your QML files with any other IDE that you prefer. I'm actually not sure the Visual Studio plugin. Who uses Visual Studio on a regular basis? Quite a few. That's what I figured. Visual Studio, by the way, I think still a rather awesome IDE in many respects. Debugger is second to none, I think. So if you're using Visual Studio for very valid reasons, there is a plugin for the Qt integration. Unfortunately, they released an updated version of it for newer Visual Studios, basically just with 4.7. So I haven't had a chance to check it out yet. I don't know how good the QML integration is with the Visual Studio plugin at this point. So if any one of you knows, I would be very interested to hear it. I haven't played with it, so I can't tell you. Yeah, most editors at this point support QML, at least on a syntax highlighting level. And yeah, you can just write it with whatever you like. You can write it with Notepad if you insist. Okay. Any questions about this example? We quite purposefully show you a bit of a richer example to see how the magic is all in figuring out what it's supposed to do and then writing down what it's supposed to do. Syntactically, it's not, at this point, I mean, it's new to you guys, but it's reasonably easy to express these things once you have a clear understanding of what you actually want it to do. I mean, figuring out what that ball is supposed to do and what that means in terms of animations, that's the tricky bit. Writing it down once you know the syntax isn't so terribly difficult. Okay. No questions? Yes, please. Could you come over with the mic there?
Just a general question, because I saw it becomes complex now. Is there a way to debug QML files?
Do you want to answer that?
Yeah, sure. Qt Creator in master, I think, does have a debugger for it. I haven't tried it out, but my understanding is that it works somewhat similar to Firebug. If you're familiar with that, it lets you Firebug lets you debug JavaScript within Firefox. But so the Qt Creator debugger does let you see what the values are of different properties and change them as well. That's what I understand. Often it's also easy just to use console.log to, it's kind of like printf debugging to see what's going on. So there's a few different debugging techniques. Another one is random rectangles. If you want to trigger your animation for debug purposes, whenever you click somewhere, it's useful just to put up a light blue rectangle and click it. But yeah, for real debugging, there is integration in Qt Creator Master.
Yeah, but that's a problem that, I mean, if you start using this in real-world projects with many thousands of lines of QML code and complicated scenes and animations and things, the debugging is a problem, especially if you're not the person who's written the code. You can read it and you can get an idea of it, but if you go into debugging the state machines and how the transitions work and all that, it can be quite challenging to debug. So we've spent quite a bit of time coming up with a few tools for introspecting the QML scene that you see, so you can debug the positioning and highlight things and figure out what's behind that and what state it's in, because if you run into corner cases of your state machine and you can't figure out how you ever got there and which property binding actually caused this, that can indeed be quite tricky. So it helps. Volker wrote something called endoscope, I think.
Endoscope, yeah.
The endoscope, the idea being that you can take a QML scene and just expose everything you know about it, or everything that Qt knows about it, all the elements, all the properties, all the types, everything you can possibly imagine, and display it in big table views and tree views. So you have basically, you poke it and it dumps out all of its internal state, and then you can go into the tree view into the actual scene tree and see what all is in there and how it relates and what the properties are and all that. And I think that Creator will probably grow into a tool like that. This is for our internal purposes. I think it's public. I don't know if it's...
I don't think so.
Yeah, it's probably...
Volker hasn't given it to anybody yet.
It's not public, not for any political or licensing reasons, but simply because Volker hasn't uploaded it somewhere. So we probably should think about making it available because it's quite useful. The other thing that I would really like to see, and I've discussed this with the Creator people a bit, the ability to actually on the fly change things inside the QML scene. So if I'm working with a designer and I want to twiddle some little parameters, it would be awesome if I could view, and that this is on the target device, which isn't necessarily my development machine. So let's say I'm running it on some phone. If I had the ability to say, okay, give me some context magical shortcut that allows me to change the animation parameters of this particular one, or allows me to just add a bit of margin so I can show it to my designer and go, is this what you mean? Because that shortens the round trip time enormously, because you don't have to go back to the development machine, fiddle with one value, upload it to your device again. So it'd be cool if there was a kind of introspection mode of sorts where you could directly edit in the QML scene. So just up pops a line edit or something that allows me to change some parameters. But you know, we don't have that yet. It might or might not happen in Creator at some point. But yeah, our friend printf, 2010, we're still printing debug output. Okay. Yeah, please.
An animation-related question. Is it possible to move an item on a Bezier curve or anything like that?
Bezier? Do they have Bezier?
You can define your own easing types. If you define a function, you know, you can define a function in X, and then call that function multiple times in your animation. So you can define any kind of curve that you like.
But there's no standard way to interpolate some points.
I don't believe so.
Okay.
But I might be wrong.
Actually, if you look at the documentation of QTimeline, which is the way underneath stuff for this, in QTimeline you'll find a description of how to produce your own time mapping function, which is the same thing here. So if you can express it mathematically in terms of a variable, then you can put it in there. So, any other questions about this example? No? Okay. Stick around if you will. Yeah, I have to give you some historical background on Steve here. Who of you has worked with model view in Qt extensively, maybe even? Fun experience? Who's written a proxy model and lived to tell the tale? Has it worked? Yeah? Okay. How many years? So the thing is, I mean, model view is great in Qt. It's very, very powerful, and I'm very fond of it. But it has this nice concept of proxy models, which tend to be rather complex, and they're really hard to get right. In KDAB, we have a song called "Proxy Models They Crash," because it's one of the main sources of problems and crash problems in Qt apps these days. Because writing proxy models is very, very hard, and few people do it well, and very few people actively enjoy it. Now, Steve here actually does enjoy writing proxy models, and if you Google around on the internet, you'll find many blogs that he's written about how to implement proxies and how to make reusable components out of proxy models. Now, for that particular reason, that's one of the reasons why I wanted him to be here today. The general problem of interfacing a QML application with existing data sources and existing data management is, I think, probably one of the most challenging parts of this. Because up to now, we've played with rectangles, right? Let's face it. We've animated little bouncy things from left to right. But any actual real-world application will have stuff that it's already managing, will have to deal with large amounts of data potentially, or at least difficult data, complex type data. So the idea of how do I get my existing stuff that I need to show into this nice and shiny animated world of whooshy light blue rectangle, that's where the rubber hits the road, right? So, and this we found exceedingly challenging because, as I mentioned, we've been working on groupware stuff, so this is email, calendaring, contacts, and that kind of thing. So that's a lot of data, complicated data, existing on disk or in memory in various formats and various representations, and how to interface that with QML was a challenge. So Steve has been working on that a lot, which is why I want him around to ask him questions about the details of the stuff that we're covering now, which is exactly that. How do I interface with my data? So at the UI level, there are some concepts that are coming into play here for working with things where you don't want to itemize them individually anymore, right? If you have 3 buttons, well, you make your 3 buttons, it's copy and paste, and you're done. If you have 5,000 things in a list view, obviously you don't want to go list view item, list view item, list view item, right? Now, the copy and paste would fail. And that's why there are some concepts that help you with doing that kind of thing. There's also accessing data. So how do you specify a particular bit of data? Where is it coming from? How do I interface with a model? There are 3 different models. And here, I'm not a huge fan of the nomenclature that was chosen. They being the people who came up with these concepts, discern pure models, visual models, and XML models. I'm not sure the taxonomy makes a lot of sense. We'll cover them all, and then you can make up your own mind whether those are good categories or not. List models, mostly because, again, QML tends to be used in constrained spaces where you don't have a huge amount of space to display lots of data at the same time. Generally, people restrict themselves to lists because trees don't really work well in these kinds of environments. Trees are also impossible to navigate with the finger because, you know, the collapse expand thing kind of breaks. So lists it is. And we'll talk about things like repeaters and delegates and how to paint the individual items. So there are 2 basic concepts that come in here. One's called positioners and one's called repeaters. Now, positioners are something that looks suspiciously like layouts in Qt widgets, which you'd all know and love, right? Layouts are awesome. So what are the basic use cases for layouts? Well, you want stuff horizontally aligned, vertically aligned, or in a grid. By and large, that's it. You have stuff like form layout, but hey. So generally, you just want some grid notion of layout. And this is what positioners do. So they have columns, they have rows, and they have what's called a flow positioner, which is something that just flows like text on a page. And then you have repeaters. Those are kind of little item creation machines that allow you to take data from a model and make representations of that data with a kind of template. Let's look at some examples. In this case, we make something, use something called a grid element. We give it a coordinate as usual, width and a height. We specify it has 2 columns, 2 rows, and a spacing of 20. Spacing, if you have ever worked with the layouting in widgets, you know as well. This is the white space in between things, as opposed to margin, which is the white space around things. Now, inside this grid, we have rectangles, 4 of them. They all have the same width and height, and they have different color. Now, this, of course, is not very nice because we have to actually itemize all the 4 rectangles. It would be nicer if we had a better way of doing that. So, but for now, let's look at the grid. It's a 2x2 grid, and the X and Y specifies the position of the first item. So everything else is laid out relative to that. Pretty much like layouts in Qt, right? So if you use the grid layout before, most of this should look pretty familiar to you. Now, as I said, it's quite not very convenient to have to itemize all the stuff in the grid, so in come the repeaters. Assuming we have a kind of a grid, we can put a repeater in there, which is an item creation machine. And then inside that repeater, we specify what it's supposed to be like and reference some variables, and they allow us to, and then it will generate the items for each row in the model. The rectangle around it is basically just the space provided to actually contain the items and the coordinate system so we can reference it reasonably. Now, this example needs a bit more explanation, I think, because there are quite a few concepts that come at you at the same time here. Again, we have a grid, 5 by 5 this time, with a bit of a spacing in between. This is hopefully easy enough by itself. So what we have there is, you can, if you've worked with layouts, think grid layout. We have a 5 by 5 grid layout. It doesn't have anything in it yet. Okay. Now we need to populate that grid with something meaningful. So what we do is we create a repeater. So that's a thing that takes data from a model and makes me items for it. We specify the model, and in this case, the model is 24. I mean, first of all, it should be 42, clearly. Secondly, how can a number be a model, right? Does that look weird to you? It certainly did to me the first time I saw it. It's actually quite convenient because what this is saying is, make me a model of this many things. Just use the numbers 1 to 24. Because it's actually 0 to 24. I don't know. So give me basically 24 things. And the way that is syntactically expressed is by saying, use the number 24 as a model for this. Make sense? I don't know. Now, I mentioned that these repeaters work like templates. So now we specify what are we actually creating here based on this model. Well, we're creating a rectangle with a certain width, a certain height, and a certain color. So what we are saying here is, make me a repeater that makes me 24 rectangles of this size. Okay? If you were to semantically understand what this, these 3 lines say. And then use that to populate the grid, which is a 5 by 5 layout, so we are 1 short. Okay? Now, usually you don't do this with the number 24. You do it with an existing data model that has the stuff that you actually want to put into your grid or into your view. But the basic notion is that you have a template and you instantiate that template for each piece in the data model, and then you parameterize it, and we'll see how that works in a minute. So assume we wanted to have something different on each item. Duh. That's why you have a data model with different stuff in it. Generally, if you wanted to have 24 rectangles, you know, that's what God gave us the for loop for. So this is not the point. The point is you have different data and you want to show something different for each piece in the data model. So how do we do that? Well, in this case, we add a text element as a child of the rectangle. And we set its text property to be index. Now, I asked whether you have worked with model view in Qt for a reason, because the concept of an index, in the case of interview it's called QModel is a very abstract thing. Now, in the very simplest case, you can think of the index as just an offset, right? It's an offset into a container. You can also think of, let's say, an iterator on a container or a database cursor or anything that points to one piece of data in the model. So in this case, we have a magical object called index, which is the current thing. That's what the template is being instantiated with. And the problem with this is that it's largely magical, right? It's index. It happens to be usable as a text. Ooh, right? So this to me is a bit too magical, but it works. The rest of the template is basically saying I want the font size to be 30 for all of the items, and I want the thingy to be centered within the parent. The parent is the rectangle, right? Here you, by the way, see another kind of issue with QML that happens in the real world, the nesting levels, right? You end up being in relatively deeply nested children of something, referencing up to some parent, and it's easy to lose context and to not realize where you actually are in the hierarchy anymore. That's why having top level or higher level items with an ID is helpful, because it kind of untangles the nesting mess. That's easy enough to refactor, I guess, right?
Right, you can specify the parent directly by ID,
yeah,
which is sometimes a good thing.
So you can pull out complicated bits into another element and then reference it, the parent, explicitly. Okay, the repeater idea gotten through? Yes? Now let's look at some actual data. Yeah, anchors. Obviously, you need to, or you want to position inside the cells potentially. So you have anchors for row, column, and grid, which means you can anchor to, let's say, the vertical center or horizontal center of a row. This would be an application, I guess, of both grid and repeater. So let's say you wanted to make a checkerboard. You would have to create all of these rectangles. You wouldn't want to create them manually, right? Hopefully. So you would use a grid and repeaters. And then you would need the index to figure out whether it's supposed to be a white one or a black one, right? So in this lab, what's supposed to happen is there is a knight PNG, which is the play piece. Obviously, in a real chess game, there would hopefully be more than that. But let's start with 1, and then you would put it on one of the squares, have custom properties called CX and CY, and bind them to the X and Y properties, make the squares clickable, and then move the piece when any particular square has been clicked. The model in this case is an array that is supposed to remember each square that was touched. And then start componentizing a bit, make the board separate, make the piece separate. So this is a bit more involved thing. Do you want to go through this? Okay.
So I'll start off again just by running this example. This again is maybe a 4 or 5 step lab. So our first step is to define and create the checkerboard. And that's what this example does, or this step in the solution does. So the first step is to create a brain rectangle for the top level. And then we have a grid of our 5x5 or our 8x8 checkerboard. I can take that out just to show you that the brain rectangle is all there. And the black and white rectangles are actually overlaid on that.
Apple Z, or actually the Y, which is actually a Z, because this.
Yeah. So these are concepts and elements that Till has just explained. We have our grid. We have a spacing between each element in the checkerboard, and then we define our repeater with our model. The useful thing about this model section is, in this case, it is an integer, but it's calculated. So we don't have to hard code 64 into here, which for a chessboard is not such an important thing to be able to do. But if you've got something more complicated, you might want to not have the value of the model hard coded. So parent rows, that's 8. Parent columns, that's 8. Our model is 64. So we get 64 rectangles. They've all got the same width and the same height, but it's the color that is different and separately and dynamically defined. So the maths of this are up to your own understanding, I guess. We first divide so the index does go from 0 up to 63. So we divide that by 8 and just get the floor to see what row we're at. Then we find out what column we're at, and if the row plus the column can be divided by 2 with a remainder of 1, then it should be black, otherwise it should be white.
Just a side note here. This is the first time that we see actual live JavaScript, right?
Right.
We've kind of glossed over this quite on purpose because there are so many new concepts to introduce. These blocks are in fact JavaScript. So this is from the curly braces to the other curly braces, just regular JavaScript being interpreted whenever the color property needs to be red, right? So you could think of this as a JavaScript closure. Now that means that syntactically we're now in JavaScript land. We have something like variables. There are no longer elements and properties, there are now variables. So that's why you have the var keyboard there. Okay? Those of you who are not familiar with JavaScript that much, that's how you say this is a variable now. You don't say what type it is, you just say this is a variable now. I think you can specify types.
You can't, and that's actually something that trips me up a lot. I often write int row equals whatever. That does not work in these JavaScript blocks. It's got to be var.
Okay.
So actually, all of these property bindings are implemented with JavaScript. QML actually inserts a wrapper function around this line. It inserts a wrapper function around parent rows times parent columns, and then it executes that function. That's how it works and how close to JavaScript you are. And if you have quite a deep knowledge of JavaScript, you can use that and use closures more to your advantage in creating these kind of UIs and applications. So black and white. Even if you didn't quite follow the maths of it, you can see the effect. The next step is just to put a night piece on there. At the moment, I can't move it around anywhere at all, so we're just literally putting the image in. Again, we've got our brown top-level rectangle, mostly obscured by our grid. The repeater with the rectangle inside it is exactly the same as before. And now we have an extra image on the bottom. And it's got some new properties which we define so that we can place it on the chessboard.
You could describe this as mapping from chessboard space into int coordinate space, right? Cx and Cy are in terms of chess piece positions or chessboard positions, and it maps that to actual x and y. That's why you have the new properties there.
Right. And you'll notice there's a little bit of magic numbering going on here. 55, that's made up by the dimension of the rectangle plus the spacing in the grid. We could take out that magic numbering, give the grid and the rectangle an ID, and we could reference directly the my grid dot spacing plus my rectangle times height. Dot height, I mean not times height. But in this example, we just use 55. So actually the night can be positioned at any valid position in the grid. The default value of Cx and Cy is 0. So all types in QML have a default. For strings, it's an empty string. For ints, it's 0. For booleans, I think it's false. Yeah. So there's also syntax to set the initial value of the thing. So in this case, I'm going to set it to 5. And the night is at position 5 over there. And again, we're indexing from 0. So we know that we can put our night in all different places on the grid that are valid at least. If I actually define a position which is not within the grid, what happens? The night disappears. Actually, it didn't disappear, it's just way out beyond the scene, or outside of the boundaries of the scene, so it's simply not visible.
Which, by the way, explains the question on one of the earlier exercises as to whether it's possible to place things outside of parents and what happens when you have negative offsets. Well, there's your explanation. It simply does the math, and if it's not in the visible area, then it's not in the visible area, and then that's your problem. Yes, there's a question there. Sorry.
Hi. Within the Java block, you have the 8 specified for the rows and the columns explicitly. Would it be possible to integrate the parent rows or parent columns within the Java block?
Sure, let's do that.
While Steve types, this is actually another one of the gripes I have with QML in practice, and having looked at the many tens of thousands of lines that we've produced, it tends to get you throw you back into magic number land, right? In C++ base, we've kind of, it's been banged into our heads that magical constants are bad. Who thinks magical constants are bad? Okay, how many do we think we have in here? I mean, just because it's so easy, and because it's code that tends to be written and tuned, in particular, by people who are not programmers, a graphics designer does not care about magical constants. Why should he not write 64 when it's 64? So, to their thinking, they don't have that instinct of going, oh, I'm hard coding a number here, ooh, bad. So what you end up with is fixed numbers being referenced all over the place and strewn over the place. So because it's more work to get the ID, to reference it explicitly, make sure you're on the right item, fetch it from, so you write 5 times 55, and who the hell knows what that means 6 months down the road, right? So that's where it gets mushy. Okay, so Steve has now successfully made this thing cook coffee.
Yep. So it's I've changed the 8 to parent.rows, and it's the exact same grid. So it is getting the number 8 from there and using it in its maths and its calculations.
But that's extra work, right? Which in your world of quick turnaround, we throw this away and redo it in 3 months anyhow software, you don't have.
So far we've got a grid, and we've got a night piece, and we want to move it around. So now we can do that. We can't move it to places which are invalid for a night piece to move, because we've got some logic in there, but we can move it to anywhere that's valid. So yeah, I presume all of you have played enough chess to know where a night piece can move. So we'll look at the code of how that happens. It should look somewhat familiar by now. We've got a rectangle, our grid, nothing has changed so far. Our inner rectangle of our black and white squares has also not changed. But within that rectangle, nested within it, we have a nested element of the mouse area, which we've seen a few times now. This mouse area fills the whole area of the rectangle that it is in, which is also quite common when using mouse areas. And we say that when the mouse area gets clicked, so that's essentially when the grid rectangle gets clicked, the white or black one, we need to execute this JavaScript. So we get a x and y. Again, this could be parent.rows. And that is the x and y coordinate on the grid, which we've just clicked. And we do the maths to find out, can this knight move to that square? And if it can, then we set the x and y coordinates of the knight to be the x and y coordinates which we've just clicked on. Now the interesting thing here is that, so our grid is 445 high and 445 wide, but what I've clicked and what I've set on the CX and the CY is a number between 0 and 7. So it's in the grid coordinates. And that is magically transformed into global coordinates, you might call them. So this JavaScript block is automatically executed when I set CX from my mouse area click handler. And that tells the knight which pixel coordinates it should be in. So you don't have to explicitly say you have to execute this function every time CX changes. It is implicit because the small JavaScript block references this particular property. So there's a property binding which says that anytime this is changed, redo this calculation, reposition this night. And that's exactly what happens. Yeah.
If you could scroll up just a tiny bit.
Sure.
Do you see that math that checks whether this is a valid move for a night piece? Most programmers I know would want to have a function or a method that checks that and encapsulate that somewhere and then have a nice check if this is valid night move and call it. You can do that, this being JavaScript. You can make a function. Thank you very much, this is so much fun. And put that nasty body inside of that to make this oh so much more readable. You have to use JavaScript syntax, which means you do not specify types in the parameter list of the function. You also do not specify a return type. I think you have to change the logic a bit. Yeah. But you can return values. So I think there might be something at the end too much. Yeah. Okay, there we go. And now we can call that.
I think semicolons are optional in JavaScript, but I'm used to putting them in there.
So the reason why I'm doing this is twofold. One is just because we're in declarative markup land doesn't mean you should throw 30 years of best practices in programming out of the window and stop encapsulating and refactoring, right? And the other thing is that this is actually very good for readability, and it helps non-programmers because you can encapsulate the tricky bits where it gets to be technical in something that they can then use because it has a name that they actually understand. Right? If you show this block to a designer, they will say, yeah, okay, if it's a valid night move, then right? They don't have to grok the math. So it really helps with separating the logic bits from the higher level UI bits. And you have that available.
The JavaScript functions can also be specified in another file and imported at the top where we do our usual import statements of import Qt 4.7 or Qt Quick 1.0 as you're supposed to use now in 4.7.1. Yeah, and so you can have all of your chess logic in some other JavaScript file.
Which gets us to the interesting question, which we'll cover a bit later on. How do you draw the line between what you do in JavaScript and what you do in C++? So where's the point at which you say this is getting too hairy now to fiddle around with JavaScript? Or put another way, this is still easy enough to do in JavaScript that I don't need to bother going down to C++. This is also a line that we haven't confidently found a clear way of drawing that line. We tend to do more in C++, but that's because that's what we know, right? So give this to someone who really knows JavaScript, and I imagine they will do a lot of more logic in JavaScript. But we'll get back to that later.
So this model property on the repeater is a bit magical. For one thing, it can take an integer and use that as a model. That's kind of magic, but there's a lot of other things that it can take as its argument and use as a model. It can use a list of things as a model. It can use, so we've got an integer, you can use a list of things, you can use a queue list of things. I should explain that. You can use an integer, a JavaScript array, which is what we use here, or you can use a queue list of T, where T can be something like an integer, a string, a queue object, anything that you can pass in through a queue variant into the QML context, or it can be a queue abstract item model. So there's quite a lot of things that you can use to define the data model of your application or of your user interface. So in this case, we're going to say that our model is no longer an integer, it's an array of things. So our first line here, a little bit of JavaScript. It says we want a variable called board, and it is an array of size 1, and it contains a Boolean. It contains true. That is a keyword in JavaScript. And you can see at the end we return the array which we create. So familiar for loop, we decide that we want another 63 things in our array. We start at 1, we go up to 64. We've already got the first true in there. The reason is because that is the start position of the night. I guess I should show the example and show you what this does. So in this new example, every time we click on the square, that's the next step. So I guess this step in the solution is just defining the array. But what that's going to do is it's going to highlight the places where the knight has already been. So at its starting position, it has already been there, it's there now. Everywhere else, it hasn't been there yet. Then our code for determining the color of each rectangle in the grid has to change a little bit, because now we want to say if it's a square that we've already visited, give it a different color, 40, 40, 40 for the black ones, and gray for the white ones. We reference the model here directly. We've given the repeater an ID now, and so we can reference its model property. Model in this case is an array, sorry. So we use the JavaScript array lookup syntax. And if you've been able to follow, the array is actually an array of Booleans, and so the Boolean at a particular index can be queried, and we can say that if it's true, give it this value. If it's false, regular black with the regular ternary operator. This mouse area has not changed. That's the mouse area that moves our knight around, and there is our knight again. So if I actually go to the next one, you can see the effect that we're trying to go for here. So every time I move to a different chess grid square, it goes a different color. I'm not quite sure if this is, a common puzzle in chess or something. Can you move a knight around 1264 positions in the grid without repeating yourself? I don't know, but it seems that that's what this this example is for. So you can mess around with it and see where you've been, and you can't go back to one that you've already visited. So I think it's quite a difficult puzzle. So we can see how that's done. So we've got our array again. This has not changed since the last time. We just initialize it to some sensible values. Our color determining function has not changed as well. It's still the same. Our onClick event handler has been modified a little bit. Rather than just setting the X and Y on the knight as we've done all the times before, we're now going to check to see if we have already been there. And the way we do that is we take from the model the Boolean which corresponds to the grid item that I've just clicked, which is determined by this little piece of math. And so that will either be true or false. At the start of the application, that will always be evaluated to false, and we have a negation here, so we enter the if loop. We set the knight to be at the position where I've just clicked, and I modify the model. So I want to say that the place that I've just clicked on should now correspond to true in the array which defines the model. So I'm not quite sure there's a need to take it into a separate variable like this. I think we could be able to do that directly. I'll just try that. I don't use a Mac usually. Oh, no, I was wrong. Okay. Well, the great thing is about QML, it's very easy to experiment. Ah, yes, indeed. No, something else. Okay. So, at any rate, it should be reasonably clear what happens here, that we modify the model to say that you've already been at this place, so you're not allowed to go back. And that's what gets evaluated here again. So, simple effect. And you can use that to solve the puzzle.
Okay, thank you. Any questions at this point? It's starting to get trickier, so yes. Can you just you lose 10 pounds today?
Just a question about the update of the colors. So whenever you change the model by setting that index to true, do we really re-evaluate all the colors of all boxes?
Let's look at the code.
Yes.
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 That's pretty slow, isn't it? Imagine it's 100,000 cells instead of 64.
I think, anyway. If I do console.log, will that appear here?
Yep, should. Oh, it's
cool.
See an Irish person and a German using a US layout with an actual German keyboard.
So I've clicked twice, which should mean. How do I drag that up?
Scrolls over there.
So it looks like it's been called about 16 times, or
No, much
a
more.
lot
than that.
more. Well, I guess it must have evaluated the whole grid twice.
Which would make sense because the variable changes, and if you look at it as property binding, you change the property, property binding body gets executed.
Yeah,
So
I would
that
have assumed it behaves so.
Yeah.
And yeah, but there are, if that kind of thing is a bottleneck in your UI, there are other models that you can use. You can define a QAbstract item model, and that might be a bit faster, or rethink how these calculations are done. I think this is mostly implemented as it is for clarity in showing you how this operates, but there might be better ways of updating the items.
Just update it manually. Okay.
you might think back, in the second session, I think, there was a reference to avoiding large script blocks in properties. Remember that? This is kind of what this is referring to, because they will be, because of the binding mechanism, they will be executed potentially a lot. So if they're expensive, you have a problem. If they're complicated, you have a problem. So it's better to make sure your data updates are actually outside of property bindings. Yes, please.
Isn't it a bad idea to put all the game logic into the file which should define the user interface?
If you ask me, it is, yeah. But
is it usual in QML?
Nothing is usual in QML because there's very little actual real-world production software QML being done at this point. And that remains to be seen. But if you contrasted it with web development, for example, where some of these concepts have been around a bit longer, they have relearned that separation of concerns is actually a good thing, and it took a while for that to sink in. Now, the risk that I see is that people will munge data logic and representation stuff and pure UI stuff all into one file because it's being done by non-programmers. This is where I think it's dangerous to say that this is a technology that is supposed to be used by non-programmers, because this is programming, clearly, right? And sure, it's helpful to have a vocabulary that non-programmers can understand and relate with, but it's fundamentally still programming. All the rules still apply. So I would very much think that it's much more logical to have the game logic external. Even if you write it in JavaScript, I'd have it separate from the UI as much as possible. So that's why, as Steve suggested, you would have a, chess moves component that has methods that you can call, such as, is this a valid move? Input and output coordinates, and separate that clearly from the UI. But I'm afraid that this is not the way that it will be used, at least not in a short and medium term, because it does lend itself to just bad practice.
But there are proper ways to do it.
Yeah, sure.
Right.
Okay.
You could define the logic in a separate file and then import it like this at the top. So there are options, but I think the way that it is now is, number one, it's good for prototyping. So if a designer, gave me this, I might be able to refactor it myself or integrate the concepts which he was trying to illustrate to me. I could rewrite them, between C++ methods and JavaScript methods and refactor it myself. But from a point of view of, teaching and prototyping, it can be good to have this stuff all in line in one file. So
there were more questions back there?
Not entirely useless.
So I have a few questions. The first of which is, I've seen sort of inconsistent use of semicolons and return. And so for properties, it appears that you do not require them, but for true JavaScript, you do. How do you know which is
Not
true?
really. It's all JavaScript. So the inconsistencies you see is that sometimes we have property assignments on the same line, in which case you do need to separate them by a semicolon. And if they're each on a different line, then you don't need that. So that's why sometimes you have semicolons and sometimes you don't. Now,
Right.
inside JavaScript, at the end of a method call or something, if you see a semicolon there, it's probably because people like Steve and I are trained monkeys, and we put semicolons at the end of shopping lists. So the same is true for whoever wrote the examples. They probably just have a few sprinkled in there out of reflex, right? Because it's just C programmer habit. So it's all JavaScript, it's all the same syntax. And as for a return, that optional return statement, I think that's what you alluded to in the block of JavaScript that we saw previously. That's a choice you have in JavaScript. There isn't anything new that QML introduces here, as far as I'm aware. It's plain old JavaScript syntax, so
Right.
you use whatever you deem the right thing to do.
It's a little bit of syntactic sugar. But again, this semicolon is a bit superfluous. I could remove it, but then I can't have the width and the height on the same line. I have to have them on different lines. So it's a style thing for that stuff. And yeah, there is an implicit return. Sometimes I'll write code like this, just to be clear to myself and how do I, yeah. And to anyone else reading the code, that the value evaluated on this line is what goes into the color property. Sometimes I'll do that. I'm not sure if it's a great practice or it'll catch on, but we'll see.
Is there anything in the property binding mechanism to avoid really doing that loop like 60 something times that we did?
We were actually wondering about this ourselves, because we have seen loops and deadlocks in the past, but it seems that, well, we started out from the assumption that no, and then we tried it, and we noticed that recently, apparently, there has been some logic added that will catch several cases at least, because we did get warnings and it plain refused some stuff that we tried out. This is recent though, so the answer is a resounding probably.
So
we haven't had time to really research in detail.
So there will be something like to check if that was the cell that was clicked and only then react on the color change rather than.
Yeah.
Okay.
Okay, any other questions about this? Yes, please.
Is index an attached property?
No.
Why not?
I don't think it's an attached property. It's an integer which is always available when you're using models. So no matter what kind of model you've defined up here we've got an array before we had an integer. The model could also be a QAbstract item model, or it could be a model defined in the QML itself, which I think we see later. But the index is always available to say which row or which index in the model we're talking about.
See, the difference is with attached properties, you use them in several contexts. So something like key navigation is useful in the context of many different types of elements, whereas index is solely useful in the context of something like a repeater, which has a model. So that's why it's not an attached property, it's just a property. Anything else? All right. Getting confused? No? Okay. Now this one we will not cover in as much detail because it doesn't really introduce any new concepts, but I did want to show it. We also have a handout for it because it is actually quite useful if you want to get your head around this. Spend an hour in, whenever you have time, because this brings together nearly all of the concept that we've covered so far. So if you want to spend time on only one lab or exercise to kind of make sure that you actually grokked all of the stuff that we told you today, do this one. Okay. Moving on to real data, right? So far we've looked at integers as models or arrays of JavaScript booleans. So let's look at some actual real data. The basic concept of model view is the same as in QWidget, so you have a separation between the things that provides access to the data and the thing that visualizes the data. That separation is useful and necessary, I hope I don't have to go into much detail about. The same is of course very much still true in QML. So there's the concept of models and views, where the models, well, I prefer to think of it as provide access rather than hold the data, because you don't want to have it all in memory, generally speaking. And the views display whatever it is in there. The actual rendering of each item is done by something called a delegate. That is exactly the same as, at least on a conceptual level, as with model view for widgets. Who's not heard of the term delegate before? Whoa. This is just historically interesting to me, because when we first started teaching the model view stuff, delegate as a concept was totally, absolutely unknown. And it seems to have permeated into the Qt conscience. So. All right. So what we're talking about here is what they call pure models. Again, bear with me on the taxonomy. This is the first kind. Let's put it that way. They provide access to data. There's two. There's the list model and the XML list model. The other kind, they call visual models, provide information about how to display data. So there is a visual item model that has items, child items, that are supplied to the views. And then there is what they call the visual data model, which is more of a non-item, abstract item model type interface. That has a delegate that knows how to render an individual item. the list model is simply a sequence of elements, as you might expect. Each list element, so those are the bits inside the list, have data. They have properties, and they know nothing about how to render themselves. This is, of course, the separation between model and view. The list element does not have any predefined properties, so anything you do with it, you add yourself. So this is kind of just a base element for list stuff that is in lists. This is what it looks like. You have a list model, which has list elements as children. And then you put something in there. You say, my list model is the name model, and it has an element that has a name property with the value Alice, etc., etc. This is just an enumeration for now, where you just manually put them in. We'll get to more complicated bits later on. The model should have an ID, so it can be referenced, and the elements are simply children of the model. Now, the delegate is a component. So there isn't a delegate element, it's called a component, and it's a component that does things. What it does is it renders parts of the model information. In this case, it accesses the name property. So you have a component that is used as a delegate. It's called the name delegate. It has a text bit inside of it, which renders the name as the text and a certain pixel size. So it's, again, the templating idea, right? You're basically providing a template for one item, and you access properties of the things that you are actually rendering there. So that implies you need to know the names of the properties, right? Now, back to putting this into work. We have a column. We have the column fill the parent, then we put a repeater in there. The repeater is the same thing that we saw on the grid earlier. Now we're operating on a column, which is the 1D vertical variant of a grid. The repeater fetches the elements from the model, just like it did in the grid case, and then it uses the delegate to display each of them. Right? The column then arranges these items and uses anchors, of course, and then makes room as needed. So this is where it gets a bit funky, I think. The list model is a dynamic list of items. So it's just a list. You can append, insert, remove, and move things within the list as you would expect. Now you can append, for example, using JavaScript dictionaries, which means key value pairs essentially, that you just instantiate and append to the list. You can remove by calling the method on the list view, on the model, sorry. Or you can move things within the model, which is how you determine positioning and do sorting and things like that. Little example. Oh, this is shadowing, yeah. Someone asked this earlier. Can you get into conflicts with property naming, right? I don't remember who it was, but someone mentioned it. This is one of those cases where you have to disambiguate, right? You cannot shadow existing properties. Especially, I mean, text is the classic, because everything will be called text, right? Or color. Okay, to maybe give you some more understandable context, let's say we have a visual item model, so that's a model of visual items. It's called labels, so we can reference it. It has rectangles. Look at the rectangles in a bit more detail. There is one that has a certain color, certain radius, certain width, certain height, and then it has text inside of it, namely books. And then there's another one just like it, with a bit of a different color called music, etc., etc. Now, let's say we have a rectangle, it's black, and we want it to contain this list of things. So we would make a visual item model like before, and then we would make a column, which is a thing that lays stuff out vertically. Think VBox layout if you prefer. We center it horizontally and vertically inside the parent, and then we make a repeater and simply say, this is a repeater that operates on the labels model, which now magically fills this column with whatever the repeater produces from the model using the delegate that is associated with that.
The visual item model, conceptually, it it encapsulates both the model and the delegate. So if you go back a slide, you'll see that it contains the actual rectangles. So the model is what rectangles are in there, and the rectangles themselves determine how they look. So that essentially brings together the model and the delegate in one element. So you don't need to define a delegate on your repeater when you define the model on it, if it's a visual item model.
Yeah, maybe let's go back to the I guess the reason for calling them visual models, which is kind of almost contradicts itself, is that you specify the visual appearance of items along with the data, right? So if you think back to queued widgets, if you have an item-based queue-list widget, where you have the stuff inside the items and you put the items to instantiate them explicitly, and you have a model that has items, that has all the stuff, and they implementationally in widgets, they still have a separate delegate which renders them, but you have one thing that encapsulates everything. That's the visual models approach. Whereas if you have pure data models, which is, I guess, why they call them pure models, you have no visual representation at all, and you specify that separately using a delegate, which is the prerequisite for not having them all in memory, correct?
You mean the pure model?
Yeah.
Yeah.
So just like with widgets, if you have to instantiate each item, you have them all in memory, right? So if you're dealing with tens of thousands of items, you want something that only renders what is actually visible, rather than sucking everything into memory.
And that was an interesting problem for us last week with Contact Mobile, because we had a date input widget. So you can specify the year, the month, and the day of the month. And so we had this model with 2,000 elements in it, for each year. And that meant that we got these 2,000 queue objects with lots of queue property bindings, because we were using each element to display the year. Potentially, this is where you choose what year a birthday is, or whatever like that, something like that. And so we switched that back to an integer-based model instead. But you sometimes have to be careful of not creating too much stuff, because it is all in memory and it's not going to go anywhere.
Yep, especially because on constrained devices, like CPU constrained devices, and especially memory, little memory and slow memory devices, lots of small allocations tend to kill you performance-wise. So 2,000 allocations doesn't sound like, or 2,000 objects doesn't sound like much, but it translates to 5,000 to 10,000 actual allocations, all of them small, none of them aligned. So that does put considerable pressure on the memory, and it made things very slow. So surprising result, but that was the problem. So views. This is now working with the pure models, right? You all know what a list view is. It's a consecutive list of things that are displayed that are coming from some model. There's horizontal and vertical placing going on. Or you have a grid, which is a 2D layout of the same stuff. The grid view is actually more like an icon view rather than a table view. So think icons in a file manager rather than Excel, right? So we have a model with elements in it. Start out from that, and then we have a component which is used as the delegate, which knows how to render these guys. It knows what to render based on the name property which is referenced there. Now, you put that into a view by saying, I want a list view, I want it to fill the parent as usual, I want a model and a delegate, and I want it to clip. Clipping, you probably know this from QPainter, means that it cuts off stuff that isn't within the area. Okay. list view by default has almost no visual appearance other than what it gets through its children or the items on it. So it's undecorated, it's flickable. This is obviously mostly useful on devices that have gestures. So I can flick all I want on this Mac, it will not do me any good. I can use the scroll wheel to have a similar effect, but it's not quite the same. But it is flickable by default, so it means it can move, it has a viewport, but it doesn't generally have scroll bars and things like that. In traditional widget-based spaces, you would do this with a scroll bar and a scroll view. If you want decoration, which sometimes you do, you want a bit at the bottom, a bit at the top, and you want to highlight the current item, you can do that. There are properties, as we will see, for doing that. You have focus, just as before, and you have highlight in addition. That's the same as the highlighted item in a list view that you know from widgets. If you don't want any of the dragging, any of the flicking, you can disable that. There is a property called interactive, which you can set to false. Let's look at an example here. There's, again, we set the model, we set the delegate, we give it focus, we tell it to clip, and then we have a rectangle that is pink, that is the width of the parent and 10 pixels high, that we use as a header. Then we have another rectangle that we use as the footer, and one that we use for the highlight. So basically, these are properties just as before, and you inline define what they look like. Making sense? This is actually quite neat, I think. It's much more convenient than what you can do with widgets. Okay, so the list view knows the current item, and I expect Stephen to start jumping me and hitting me over the head with a bottle or something, because I know that there have been numerous problems with figuring out what is actually current and what is actually selected and how to manage that. Someone else was just... no. So yeah, that gets tricky, but he can tell you more about that, I guess. So for now, we just have a text. We give it a label again. We align at the bottom. We align centered horizontally. And then we say something like, take the list view's current item and then access its text property and make that bold and print that that is the current item. So this is supposed to tell you that you have access to the current item as part of the list view's properties. So if you programmatically need to do something with the current item, that's how you get to it. You are lucky if all you have to do is print the text. Generally speaking, you will have to do something meaningful with it, which is not quite as easy. Okay. So you can have sections in there, which is also quite useful. And the way you do that is, again, by mumbling the right magical incantation. Basically, you choose a property name, let's say team, something that defines your categories. And then you simply assign values to it. And if there is such a property in the list elements, and if it's the same for all of them, then those will be used as groups. Ooh. I feel like I need to put on a black pointy hat at this point. This is getting way too dark magic for me. Because, I mean, obviously, if you haven't read the documentation or been in this room, you have no clue how this is supposed to work, right? This doesn't seem very guessable to me as an interface. I might just be old-fashioned. What do you think? Good idea? Not a good idea? Okay. One very good idea, which is being pointed out to me rather ferociously over there, is that we should take a break. I suggest we do that, and then we get back to integrating with C++ back and forth and all the fun stuff. Okay, I'll see you in 15 minutes at 4:30.
15 minutes.